Joshua, any difficulty? Shall we start?
Yeah, okay, we'll start now. We'll start. Okay, I'm sharing my screen. I am
Okay.
audible, right?
Yes, yes.
Okay. Is the screen visible? Can someone?
Yes, sir. Yes.
It's visible, no? Okay. Okay. So we'll start. Uh, Good evening, everyone. Thank you for coming to this orientation session. I will be giving a very short overview on the course Electronic Product Design, EPD. It is a core course, part of the BS degree program. The course code is E4102. Uh, and the faculty, the faculty taking this course is Professor L. Umanand. About the faculty, so Professor Umanand, he's a full-time faculty here in the Department of Electronic Systems Engineering in IISc Bangalore. And so his areas include electronic system design and power electronics, photovoltaics, and so he works on a range of fields, with the main focus being power electronics. So this course uh, is uh, is like a stepping stone into uh, real life applications and what actually happens in actual electronic systems that we see in industry. Uh, so yeah, can you see the slide, the second one? It's visible, right? Yeah. So this will be the main focus of this course. That is, we will be talking about the generic electronic system, and these are some of the topics that are there that will be covered in this course. So if you see this course, it is a combination of several things that you have studied in your foundation program and your diploma program. Many of those things that you studied actually comes together here. Uh, and so this is because I assume you would have already done a course on op-amps. So your op-amps thing that is here, we'll be discussing on op-amps also, which is part of the analog signal processing. Then there'll be something about digital filters. I think there's another DSP also, that is a digital signal. That is part of digital signal processing. And then we'll be talking about controllers. And so this is a rough block diagram of your electronic system, and throughout the course we will be revisiting this block diagram, and through the course we will be talking about each and every block of each and every part of this entire block diagram. And so this is the plant, and so this is the system that we want to control, the plant. And it can be a DC motor, it can be any of your loads that are there. It can be an AC load, DC load, it can be a battery, it can be anything. So this is your generic electronic system. And so these are uh, some of the topics you can see in the right. And so we will be talking in detail about power supply design. And so all of these actual electronic systems, they will have a lot of analog circuitry, digital circuitry, they will have different controllers there, and they all need different power supplies to work. And so how do we produce these power supplies? And so those circuits to produce like 5 volt power supply, 3.3 volt, 12 volt, 15 volt, like we'll be talking about those different power supply circuits. And so that is what is the first part, linear and switch mode power supplies. And many of these circuits have switches, which could be BJTs or MOSFETs. And so you have driver circuits to drive them. So base, that is the base drive and gate drive circuit. We'll be talking a little about pulse width modulation. And this is something that probably you would have not learned, that is about magnetics design. So we know that our capacitors and resistors and all are available ready-made parts in the values we want, but inductors are not that easily there. And so uh, and we have many circuits where we need to use inductors, transformers, coupled inductors, these things. And so we will be going in detail on how to design them as per our application demands. And then, as I said about op amps, then you have your analog signal processing. There'll be digital signal processing. Then we learn about control systems. I think you have gone through a course that talks on control systems. So we'll talk about your Bode plot and stability and root locus and things like that. And then we'll be going through a little bit of coding as well, as a basic microcontroller coding using your one controller called AT Tiny. That will be at the end of this course, and there we will take an example system, a plant, which is your DC motor, and we'll be expounding on that. And to get more ideas, so this is just a rough overview of uh, this course. You will learn a lot of practical things in this course, like reading a data sheet and designing a system from scratch, and writing the design equations, and making sure all your constraints are matching. And we are actually this is like a course where you bring the different puzzles together. And so you would have separately learned op amps, you would have separately learned about controls, you would have separately learned about linear power supplies, or and so this is the course where you actually bring them all together and see how they work together as a system. uh, more information on the course, you can see the YouTube playlist that is there, or also in your course page. There also you can access this entire playlist to get a detail on all, in detail, what all topics we are going to cover. So I will go to the grading of this course. And so we will have the grade assignments 12 weeks. And so 12 weeks grade assignment, and all the graded assignments of all 12 weeks together, we will be considering all 12 weeks, and that will consist of 30% of your final weightage. Then you will have quiz 1, which is based on the syllabus covered in week 1 to 4. That is 20% of the final weightage. Same goes for quiz 2, week 5 to 8. That also is 20%. And then you have your final exam. That's the entire syllabus, week 1 to 12. That's 30%. So 30, 20, 20, 30. This together is your comes to 100%. And then there is a uh, bonus component, and that bonus component will be based on the course project. So there will be a short course project. We'll be learning to design a power supply circuit, and so that course project will include you doing a very detailed circuit analysis, as well as we'll be designing the PCB also. So finally, you will have a feel on what it is to design a circuit, and then go into the PCB designing aspect as well. So I think that is sort of what this course is about. And we will so those who enroll in the course, you will be added to a group in Google Chats. And so all our communication will be through that group. And uh, so you can go through the weekly contents and then the grade assignments. And so you have any doubts, you can ask me anytime in that group, and I will try my best to answer it in a day. Uh, and and so all the most of the interactions will happen there. And most of the interactions will be happening there. And then we will also be having live sessions. And so like live sessions will be like once in 3 weeks, like that. Mostly we'll have live sessions before the quiz as
আরে
well.
পিছন থেকে তোর এটা কি বলে তো তুই
Before quiz 1, before quiz 2, before final exam also, we'll be having like a live session, and you can share your doubts or clarifications that you need. But you don't have to wait for the live session to share your doubts and clarifications. You can always ask it in the through the Google Chats, and we can clarify it as soon as possible. So yeah, that is all from my side. So thank you. Any questions? Any questions? Are there any questions? Any doubts?
Okay, I don't think so, Joshua. Thanks, Joshua.
Okay, then yeah. Thank you
Yeah,
guys. So see
thank
you in
you.
the course. So yeah, okay. All the best.
Okay. So let's move on to the next course, which is Embedded Linux and FPGAs. Prabhu?
Just a minute, I'm sharing my screen.
Yeah.
I hope my screen is visible to everyone. Yeah. Is my screen visible? Hello?
Yes.
Yeah. So welcome you all. So this course is a degree level course, and this course is all the title of the course is Embedded Linux and FPGA, and the professor is Professor Nitin Chandrachudhan, and myself, N. Prabhuram, and Shubham Gore, I are the course instructor for this course. So what are you going to study from this course is we can start learning. We just facilitate you how like learning how the software controlling the hardware. That's the primary focus we handling in this particular course. And for that case, what are the things like how the CPU is communicating, like how CPU defines software with software like Linux based things, how it is communicate with the peripherals, and how especially through the method of memory mapped IOs. I hope we are already gone through these things in the embedded C programming, and we're going to execute the same thing with the help of Linux, and going to build a very small IP code, and that's supposed to work with embedded Linux. And this, so the small IP code is going to design with the help of Verilog code, and then that is going to control through the software of embedded Linux, and we're going to execute. So this is what you're going to study, and we are going to learn that is a basic thing like learning embedded real-time embedded system, and how it's going forward from the hardware IP core till the controlling of everything. Like that's what you're going to study in this particular course. And learning outcome from this after completion of this course, so you will, I hope we can able to explain what is MMIO, how it is explained, how the MMIO is works, and what is mean by registers, and all these things that we're going to discuss. And we're going to discuss about what is AXA protocol, that is what we have studied in the digital system design course also, which is very theoretical level we will discuss, but we go into studying in detail about it, how AXA supports you to communicate among the IP cores and the other peripheral unit, especially the CPU and other peripheral unit. And then we're going to study we don't from the registers, that is memory map IO, how we're going to read the content from the memory map content, and similarly how it write into the particular register. And these things supposed to be controlled with the help of operating system Linux. And then we're going to increase the level of coding, like with the help of device tree, and that describes what are the things are there in the hardwares, and how it is going to interface, which location, all these things, fundamental software level device tree mapping we're going to discuss. And so along with that, we're going to adding some more extra peripheral like interrupt handler, and how it is helpful for debugging your problems with the hardware and software. These are things you're going to at the end of this course, I hope you will learn as an outcome. So again, the objective of this course is just mapped IO and AX interfacing, and these things we going to interface with the help of Linux kernel and drivers. For the driver concept, like IP cores supposed to interface with the hard software with the help of driver concept. So for that, we learn what do you mean by driver, and how do you write the driver codes. And then we're going to mapping that IP code with the help of Linux through the device tree blocks, device tree software codes. And then we're going to build a complete system integration of all these things together. This is our goal. And primary prerequisite is you're supposed to familiarize a basic pointer concept, what is memory mapped. That is what you studied in embedded C programming, like register by suppose I'm using GPIO means what port I'm using, what is the register path, things we have used, what is the address of that register. That's theoretical understanding we require, and practical understanding how the pointer behaves. All these things we need to back up it, just revise it up. And then from the digital system design, we again expecting you to be familiar with the Verilog coding in writing code for basic architecture like simple CPU, simple ISA, and sequential logic and final state machine model. All these things we have to please recap it before this course begins for better understanding. And why this course is helpful for us is in the modern system, we aren't really build up a very complex hardware system very easily. So for a better high performance software is helpful, but purely not software is enough. So we have to integrate both the software and hardware. So that's what this course is helpful for us. So in the software wise, we are using a Linux, and in the hardware wise, we are using the IP course, and we are interfacing all the things. And what are the things are included in this particular courses are MMIO and AXI. And how that's what I mentioned just now. MMIO is helpful that we can communicate through the AXI bus protocol, and that software wise we are using device driver and operating system as an interface. And course outlines, or we going to interface hardware like registers, and that register is viewed through the memory map. Just through the software, we are going to write the device driver codes, or kernel modules, and for the better for the understand for security level, including the platform drivers, all the things we're going to include in this particular course. And especially in this course, we are not including we are not focusing on the advanced drivers and buses like PCI interface, which is using in the x86 board. That things we are not including covering up in here. And we are not deep dive into the operating system, like we are not talking about the what is scheduler, how the resources managing, and how the deadlock handling. All these things we are not taking too much of it. Maybe if you this might be the good insight for this to understand if you take a proper OS based for courses. And this has added to the funda. So weekly course, like in first 2 weeks, we just refresh about the MMIO basics and the AXI interfaces. And week 3 and week 4, purely operating system concept, like very foundation level, essential level elements like Linux drivers, how we going to create a module, or how do you insert the module and remove the module. And then we can do the demonstration of all the things with the help of emulator. We can run that thing. We can create our own customized kernel also. And all these things we're going to discuss from week 3 and week 4. And week 5, we adding some extra feature like platform driver, which is helpful for not mentioning for enhancing security, like this address is not need to mention, this is a physical address and so on. So for that, we are including something called device try and device tray platform drivers, which is going to discuss in week 5 and 6. And week 7, we are interfacing the softwares of device trees as well as the hybrid course. That is what we are doing in week 7 and week 8. And week 8, we're going to discuss inclusion of interrupt, and 9 also inclusion of interrupts and enhancing for better performance. And week 10, we're going to discuss about what is DMA and how the DMA is introducing. And week 11, we are introducing the booting, of how to, after completion of the kernel which you are compiled, cross-compiled, how you flash it into the SD card, and what are the primary things used for the boot loading. Okay, and we're going to discuss something called performance improvement. What are the things we're going to include here? That is, we're going to discuss in the week 12. And the tools we are using are, and the hardware design, we as usual in the previous course, like in the digital system design, what are the hardware designs like Verilator. Here we are along with IRS, we may be including the one more converter like a Verilator compiler called a Verilator. And for the visualization purpose, we can use GTK Wave. And we're going to include one more hardware tester, which is software tester, which is called as CocoaDB. We're going to test the hardware with the help of Python coding. And software for the emulation purpose, we're using Renault platform. And programming C and the kernel Linux driver modules are the software things we're going to use. And cross compiler, we are using ARM GCC compiler we are using. And so now come to the topic on assessment. In the as usual, we have 12 weeks, and each 4 weeks we have conducting 1 quiz 1, quiz 2, and end term. And the materials for this, and we are referring for understanding about Linux driver. This is an open book. First one is open book. We can use it and learn better depth of it. It's a very huge book, like same, but how the C programming, the same Same like that, it is a very good book, and other online materials also available. We can explore it. And the grading patterns, 10% weightage is given for the graded assignment, and remaining is max of 50% final score, and 20% from max of quiz 1 and quiz 2, or 40% from final score, and 25% each from the quiz 1 and quiz 2. So we are again, I am expecting you to please use the Discuss forum for the discussion and the live session. Weekly once we will conduct one live session and they can, if any clarification, please discuss with us. Thank you. Any question?
Any questions from any student?
Sir, what about lab component?
Yes, the lab component, we have going to boot. See, in the week 3 onwards, we are discussing something like how to create our own kernel, customized kernel, and adding one of the hardware module. We, from the entire course, we are using only one hardware module, which is a simple IP core like a timer module. And that timer module, we going to acting as a one of the IP code or driver code, and that code is emulated using Renault. So far, we are doing in the theory part, we are going to do these things in the simulation level or emulation level. In the lab component, we just use the same thing in the hardware, and we start to build from the our own hardware, like a thing Z2 board we are using.
So it will be completely online, right? No need to come to campus for lab.
No. For this lab, we have to come to the campus. Till if you have any for further clarification on the Renault elimination, please join the live session. We can discuss and we can enhance ourselves also. Okay. So for the lab part, we have to come to into the campus. Okay. Any question?
Okay. Thanks, Trivram.
Okay.
Moving on, the next course is control engineering. Vasmati.
Yeah.
Yeah. You can.
This course is control engineering course where starting from how to learn riding a cycle and till missile launching, everything needs control settings, right? So this course is a starting level course where you try to learn how to visualize a system, how to define a system mathematically, and learn some tools to handle those systems, and then ultimately how can we design a control algorithms for a system to get an output as desired as possible. So if you see in this graph, the innermost, we will start from the very basic things, innermost layer, what is feedback, discrete time, continuous time. We will discuss about the time domain, frequency domains and everything, and we will slowly try to move forward until this shaded regions where you learn about most of the course covers about the linear systems and part of the non-linear systems. How can we linearize those non-linearities in a real-time systems? And then some of the representation, different kind of representation of a system. How can we represent the same system in very different forms that are suitable for different kind of tools what we want to use to analyze the stability or controllability or anything to design a control system. And then we will discuss very small portion of that about the filtering techniques for noise filtering and all. So overall, this course is a basic course where you can learn to handle the tools, and then later by using those knowledge, you can go ahead with the advanced courses in controls like adaptive control or non-linear control, predictive and all. So this will be a first stepping stone of the control period. And in this course, so as I said, first 2-3 weeks we'll be discussing about the system identifications. How can we represent a system? And the 4 to 6 weeks we will be discussing about what are all the tools we can use to analyze those systems. And the later weeks will be covered around the control algorithms to get the desired output response out of those systems. And when we ask about the course or grading policy, we'll be having 12 weeks. 12 weeks content we'll have, and every week we'll have an assignment. Out of these 12 weeks assignments, 2 will be a handwritten assignments where we will evaluate offline, but you can submit it online. And there is one grade design assignment in this course where you will be given with a problem individually. It's not a common problem according to a roll number or some criteria. We will design those problems. You have to answer it individually. Based on that, we will evaluate those design assignments. So along with this 12 assignments, we have another one design assignment. It's a very 1 or 2 problems, 2 design assignments we used to conduct. So if we talk about the weightage, the 12 weeks assignments, but not generally we will include the 11th week and 12th week. First to 10 weeks assignments will be weighted around 10%, and the first and second quizzes 50%, and the design assignment carries 5% totally. So this is how your weightage will be split. And we'll be having 3 live sessions in a week. You have 2 course instructors. One is myself, another is Chakravarti Jada. He's not joining. He didn't join now. So we'll be having 3 live sessions. You can ask doubts and we will solve problems on those assignments. We'll solve problems on those assignments. Sorry, live sessions. And we will be connecting in the G space. You can ask doubts or any queries. You can post it in the G space. We will communicate through that. That's it over to discuss. If you have any doubts, please ask.
Yeah, any doubts from anyone related to control engineering? Okay. Okay. Thanks, Osmita.
Thank
you. The next course is shown here. Next is strategies for professional growth. Ram?
Yeah, hi. Good evening.
Yeah.
Okay. Can I have a quick show of hands as to who are all electronic system students here? Or a thumbs up? Okay, Pratham. Anyone else? Pratham, I saw Doru Munjal asking questions. Any other students? Okay, Manoj. 3, Khalil, 4. Okay, fine. Okay, the course is named Strategies for Professional Growth, in short SPG. This is a common course for both the data science degree students as well as the electronic system students. So you will be working with the BS data science also when it comes to this course. This is a mandatory course for the HM credit, and the grading pattern you can refer to the Jan 2026 grading pattern that has been shared by the support team. The components in this course are weekly assignments. There is no quiz 1. You will have only one quiz, which is quiz 2, and it has both subjective as well as objective type MCQs and an end-term exam. One major component in this course is a team project, which will be a sort of experiential learning or your own personal development aspect. And you would be interacting with external stakeholders who are not associated with the IIT MBS program, and then deriving some sort of qualitative insights from that interaction and doing a secondary research as to how the topic that you are exploring is fitting into the current world setting, and presenting it as the final report. So what exactly is covered in the course called SPG? If you look at the World Economic Forum's Future of Jobs Report 2025, you can search it on Google, Future of Jobs Report 2025. There will be 10 top skills that are relevant for the year 2025, core skills of 2025. You will find AI and big data at the top, network and cybersecurity next, and it goes on like technological literacy, which is a generic term that covers all the technical aspects of any domain knowledge. And then comes something which is not related to any technical sphere. It would be in the field of cognitive skills, management skills, and in short and simpler terms called people skills. You will find terms like creative thinking, resilience, agility, working with others also. So such topics are being covered in this course, and the modules are listed here: cross-cultural management, personal finance, system thinking, teamwork also. Say, for example, you are completing this degree and you are seeking opportunities in the semiconductor industry and you want to go to Taiwan. How would be your uh, interaction with people who are of a different culture, or you want to go to Japan, say East Asian countries compared to your work style in India. So such aspects of culture shock or the uh, conflict management aspect you will be learning in this course on a surface level. No technical depth or the theoretical concepts will be covered. It's pure application basis. So you can take a look at the playlist that is available on the BS degree YouTube channel, and then go through the topics that you want to pick for a project right now itself. One thing that I want to emphasize here is you must be working in a team project combined with the data science student also. So don't be under the presumption that you would be working with the electronic systems whom you already know. So it is well and good to reach out to the team members or whom you know in the BS data science program, and also taking this course in the upcoming Jan 2026 term right now. If not, do not worry. When the course starts, the course team will be there to help you guide in choosing the team members. Other than that, the generic grading components are there in the pattern. You must be getting 40 out of 100 in the weekly assignments to be eligible to take the interim examination. These project components carry 25 marks, so it's a significant component. Apart from that, one thing that I want to emphasize is the weekly assignments. Similar to the projects, there are case discussions that would be happening. Case will be given to you prior to the along with the weekly content release, and you must be forming temporary groups, which is not same as your team project. It will be in the size of 8 to 10 members, again combined with the data science student also, and you would be conducting a discussion among yourself or a role play activity or a skit, and then submitting the recordings of the video as well as your own self reflection of what you are going through on a discourse post. So this assessment also carries a significant mark up to 15. So 10 weekly assignments, 15 marks, 1.5 each. So please bear that in mind. And in terms of time commitment, you would be required to spend 2 to 2.5 hours per week for this course. Therefore, if you are planning to combine this course along with any other degree level courses, please plan accordingly. You can feel free to interact with the seniors who have already completed this course in the electronic systems program, or reach out to me via email. I'm dropping my official email here. You can write to me for any clarification with respect to this course. If you have any doubt, please feel free to post it in the chat. I'll be happy to answer. That's all from my side. Thank you.
Thanks, Shyam. Any doubts or any questions?
If it's the first term of my in degree level, then it's compulsory to take SPG, no?
I'm not sure about that, but you should have completed all the core courses, including this, in order to move to the elective courses, is what.
Yes, that I know. But the last two terms it happened uh, like in the entering phase you have to take SPG. Then you can choose other subject also.
Okay, this thing I'm not aware of. I
Okay.
would request you to check with the support team.
Okay. Uh,
Okay. Uh, okay. Any other questions? For any other courses? I mean, not only SPG, any degree level courses, if you have questions or doubts, you can ask. Okay. No questions? All right. So if no questions, I think we can formally end the session here. I would like to thank all the instructors who have joined and presented their course insights and all. Thank you so much, and I would like to thank other students who have joined and raised their concern questions. Okay, so thank you all
uh,
for joining.
do
Yeah.
we not discuss any other courses? Means like VLSI
So
is
the
there
other
also.
courses, yeah, I know. The other courses, instructors are not available. If you have any question, you can raise. If we can answer, we will answer.
Okay. So like what's given in the table? Only VLSI, I guess, left, not discussed.
Yeah, I understand. So the instructor is not available. So
Okay,
any
okay. Fine.
specific doubt related to that course you have? Something like grading policy is anyway out. So you can take a look at the grading document. There is
Okay.
no major change. That is the standard. You have GAA. So the components that are there are GAA, quiz 1, quiz 2, and enter. And the very standard max of max form.
Yes, yes.
Okay. And this electromagnetic field, EMF-TL, is also the same thing.
Yes, yes. That
It's
that EMF also. Hmm.
yeah, EMF-TL.
Uh,
That also the same thing. So no prerequisites. The components that are there are graded, quiz 1, quiz 2, and final.
One more thing, like that VLSI semiconductor is being shifted to a compulsory course, or it's still in a degree elective.
VLSI is still a department elective.
Okay, so
Yeah,
okay, for
yeah,
this January 2026, it's in department elective only.
yeah. In January
Okay.
26th also it
Okay.
is elective. All right. Thanks all for joining. Have a great day. Bye. Host, you can end the meeting.
Senior na? Senior na? Senior na?